Welcome to all of you. Hey, we are continuing in section 2.6. We already have gone over our learning goal for this lesson, which is to learn to write a two-column proof to prove statements about segments and angles. And what I told you is that we need to see another video in this section just because proofs, well, they're a little bit tough until you've seen enough examples and tried enough on your own. And so we're going to continue to do examples. This will be the last video for this section, but then we'll have several videos with proofs in coming lessons as well, because proof is going to be a pretty important thing, as I've been telling you over and over again, going forward here for us. Alright, now, the other thing we did previously was we learned some theorems for segment congruence and angle congruence, the reflexive, transitive, and symmetric properties of segment and angle congruence. We'll use a couple of those within the two proofs that we're doing in this lesson, but I just want to remind you that that's what section 2.6 has been about. Okay, so here's another proof for us to write. You need to go ahead and take the time to pause the video and copy down everything that you see on the screen right here below the title. And the title is not actually a bad thing to have either, but you've already got notes for 2.6, so you've probably already got the title written down. Copy the given statement, copy the proof statement, copy the picture, copy the statements and reasons columns. Go ahead and then we'll come back and do the proof. Alright, so let's talk about a strategy here, and then I'd like you to actually try the proof on your own as much as you can. You're welcome to watch me do a little bit of it first if you need to, but I'd like you to try it on your own as well once we've talked about a strategy. Here we're told that angle 1 is congruent to angle 2. And we're trying to prove that angle 2 is supplementary to angle 3. Alright, well, one of the things that we need to understand about this is what does it mean for two angles to be supplementary? And we, of course, know that if two angles are supplementary, that the sum of their angle measures equals 180 degrees. So somehow we've got to show that this angle measure plus this angle measure has to equal 180 degrees. Well, I hope that as you look through this picture, you see another pair of angles that have to be supplementary to one another. And that's angle 1 and angle 3. And why do angle 1 and angle 3 have to be supplementary? Well, think about what kind of angle pair they are. That's a linear pair, right? And we've determined in chapter 1 that linear pairs have to be supplementary. So we can show that the measure of angle 1 plus the measure of angle 3 has to equal 180 degrees. And then since the measure of angle 1 equals the measure of angle 2, you can then say that the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. That's the strategy for the proof. Try it out, and, well, then check here in a few minutes after you've paused the video. See if you got it right. Alright, here you go, and I hope you've come up with something close to it. And if you came up with something that is close to it, it's possible that yours is still right. You need to pay particular attention to whether your statements are in a logical order and whether the reasons that you're giving actually support the statements that you're making. Alright, now of course you got the first statement and the last statement right. Okay, that is a 2 there, I promise. Because whatever you're given is always your first statement. Whatever you're trying to prove is always what you end the proof with. Alright, and then of course you knew the first reason is that is given. The reason we know angle 1 is congruent to angle 2 is because that's given to us. Okay, now we said that we're going to show that the measure of angle 2 plus the measure of angle 3 equals 180 degrees, since the measure of angle 1 plus the measure of angle 3 also had to be equal to 180 degrees. One of the things that you might not have thought of on your own, but you'll get used to this, is that we were going to have to use substitution in order to take this equation and make this equation right here. And anytime you're going to substitute, you have to be working with equations, not congruent statements. Alright, you can't substitute into a congruent statement, but you can substitute a value into an equation in place of an equal value. So, I had to say that the measure of angle 1 is equal to the measure of angle 2. Make an equation out of the angle measures rather than just continue working with this congruent statement. And the reason I know that two congruent angles are equal in measure is because of the definition of congruent angles. That's what it means for two angles to be congruent to one another. Alright, now that was really the only thing we could conclude with our given statement there. But when we went to the picture, we noticed that angle 1 and angle 3 are a linear pair, and linear pairs have to be supplementary as we discussed in our plan. So that means that the measure angle 1 plus the measure angle 3 had to equal 180 degrees. Okay? And you can simply state for your reason that linear pairs are supplementary. That's a fact. Actually, in the next section, we're going to learn that that is a postulate called the linear pair postulate. It tells you that linear pairs are supplementary. Okay. And then, since the measure angle 1 equals the measure angle 2, right, we saw that up here, I was able to replace this measure angle 1 with a measure angle 2 in that equation by using the substitution property of equality. And you might think that, hey, doesn't it mean that when the measure angle 2 plus the measure angle 3 equals 180 degrees, the angle 2 is supplementary to angle 3? And so aren't we done with the proof? Well, keep in mind, you have to finish with the exact statement that you're trying to prove. It needs to be in that form. And so I had to go from where I said the measure angle 2 plus the measure angle 3 equals 180 degrees to saying, in words, angle 2 is supplementary to angle 3. But you were right to say that this means that because that's what the definition of supplementary angles are. If the sum of two angle measures is 180 degrees, by definition, then they have to be supplementary. So that's why we were able to conclude that angle 2 is supplementary to angle 3. Great. Hopefully this is making a lot of sense to you. Get to say it a lot, don't I? But I mean it every time. All right, let's do one more proof here in this video. Ignore this title right there, the proofs for symmetry of semicongruence. I don't know why I left that in there. In fact, let me just cross it out real quick. And then while I'm doing that, you guys can go ahead and begin the process of copying down all the information that you need. Okay, so do that real quick and then unpause the video and come back and let's do the proof. Okay, let's talk about our strategy right here. We know that segment JK is congruent to segment MN, and that the distance from J to K equals 5, and the distance from L to M is equal to 5. Tell you what, sorry, I'm changing up this information a little bit. This middle statement that I gave you, change that to segment JK is congruent to segment LM. Alright, the other proof wasn't exactly what I was trying to show you. I would normally just change it in the middle of a video, but in this case, it kind of needs to happen. Okay, so my apologies, you've already got this marked down. You may have already finished that other proof, and hopefully that went well. But let's do it with this information instead. And we're going to start by marking this information down in the diagram. Alright, so again, I was explaining a strategy here for the proof. We know that segment JK is congruent to segment MN, and now we also know that segment JK is congruent to segment LM, and then we know that LM is equal to 5. And so we're going to prove then that MN right here also has to be equal to 5. And our quick strategy for the proof before you attempt it. If we know that segment JK is congruent to segment MN and that segment JK is congruent to segment LM, well, doesn't that mean that segment LM has to be congruent to segment MN as well? And there's a certain property that would justify that. Okay, and so then if those two segments are congruent, then their distances are equal, so you'll be able to prove then the segment LM and MN are the same length, and so the MN is also 5. Try it out, see how you do. Alright, here's my version of the proof. I'm almost guaranteeing that yours looks a little bit different, but that doesn't mean yours is wrong. Though the main thing that I did here that you would have done differently is I saved one of the given pieces of information for a little bit later in the proof. Alright, now you're not incorrect ever if you include all the given information in the first step. There were multiple pieces here. However, sometimes logically, it makes more sense to save some of that information for later in your argument. All right, and that's what I did right here. What I wanted to do first was start off by showing that segment MN and LM had to be congruent to one another, and the only pieces of information in the given statement that were relevant to making that conclusion were these two right here, that segment JK is congruent to segment MN, and segment JK is congruent to segment LM. Alright, well, given that that's true, that means that segment MN and LM are each congruent to the same segment. And if two segments are congruent to the same segment, they must be congruent to each other based on the transitive property of segment congruence. Now, I always need you saying, when you use the transitive or reflexive properties or whatever, whether or not it's a property of equality or a property of congruence. And in this case, it was congruence, and it was for segments in particular. It wasn't for angles. All right, it wasn't for triangles or anything like that. It's a transitive property of segment congruence. All right, now, of course, once we were able to say that segment MN and LM are congruent to one another, we are hoping ultimately to be able to replace the length of MN or LM with the length of MN. All right, we needed an equation to do that ultimately. So I switched to equation form right here. I went from the segment MN is congruent to segment LM to saying that their distances are equal. We've used the definition of congruent segments many times by now, so hopefully you understand that logic. And then I went back, because I was ready to ultimately say that MN is equal to 5, went back and said that LM equals 5 now. All right, this is where the 5 becomes relevant to us, so that's why I saved it to this point in the proof. And if LM equals 5 and MN equals LM, then we can say by the transitive property of equality, because these are equations that we're working with over here now, that MN is equal to 5. All right, let me do a little bit of highlighting just to make sure that last part makes sense. We knew that both MN and 5 were equal to distance from L to M, so then they had to be equal to one another as well. That's how we finished that proof. Alright, thanks for watching. Good luck with your proofs. Remember to finish all your assignments over your break that you haven't finished in class, and I will see you next week when we get back in class.